Hello everyone. In this video, we are going to talk about how the bar is law. Uh, Before going on further, I'm going to talk about what is special about this law. Um, we have already gone through uh, some topics about MPS law, but MPS law itself is not enough to solve some specific problem. MPS law would only allow you to determine the magnetic field uh, of an Ampere's law. So to start with, let's investigate some history of this law. And first of all, the Russian scientist Biot-Savart discovered this law experimentally, and they discovered it about 40 years before Maxwell. And suppose you have a current segment here, and this little metal segment has the length delta L, and the current is running from left to right. And in the previous chapter, we have learned that if you have a current, if you have a current flowing along the conductor, metal wire, for instance, you will produce a magnetic field, and the magnetic field will be somewhere here. So in this case, uh, by William's goal rule, the direction of the current should be here. But uh, in this episode, we are we are going to determine the magnetic field somewhere very far away, not here. Instead, we are going to detect the magnetic field at the observation point A. So in this case, if the direction of the magnetic field right here is pointing out of the box, then you will experience something similar at point A, and the direction again will be pointing out of this white box. So let's assume the distance between this little wire segment and the observation point is A, little a here. And the angle formed between the metal segment and the observation point is, say, theta. So let's assume that the horizontal axis is x-axis. So uh, then there will be a magnetic field generated at the observation point A, and the magnetic field will be dB, delta B. And by Biot-Savart's law, dB is going to be mu I times 4 pi, and then PL sine theta divided by A squared. So this is the Biot-Savart law presents in scalar form. And you may wonder, right, whether it's possible to convert the expression here into a vector form. The answer is very easy. Right now, uh, uh, we have this term here, what mu I divided by 4 pi. Mu I divided by 4 pi has nothing to do with the geometry of this setup. So this one uh, will be excluded for consideration. And then we have only one variable on the numerator that is related to the direction or geometry. We have a delta L here. Delta L, uh, so we can say that PB and this P is going to be a vector, and then I for pi, and then PL, which is another vector, uh, and uh, we have a magnitude here, and here is a magnitude, and sine theta, and A. A is the magnitude uh, in this separation, in this distance. So we have, we can convert it into a vector, and then we are going to use the magnitude to represent it. So hang on a minute. Uh, can we insert another unit vector? And the magnitude is 1, and the direction is A into here. So in this case, it's not going to change the value of the original formula. So let's say we have a unit vector with magnitude 1, and we are going to insert it here. So now you basically have two vectors, the two magnitudes, the magnitudes of two vectors, and then followed by sine theta. So when you have this thing here, you have two magnitudes, and then sine of the angle between these two magnitudes. So why don't we just assume this as uh, A and then cos B. So in action, the numerator can be converted into uh, uh, A hash cross cross product with the vector DL. So in this case, if we convert the whole formula into the vector form, and we are going to have something like this: A hash cross product with delta L, and then the magnitude of A, the square of the magnitude of A at the denominator. And you can also present the formula in this manner. A and then cross product with L, and divided by the magnitude of A to the power of 3. So this is the Biot-Savart law presented in vector form. And so this is the Biot-Savart law, and uh, the scalar form of the formula is here. The vector form is here. And remember, the direction of dB will be 90 degrees orthogonal with the direction of current. I mean the direction of dl.